Hi guys, and welcome to another ESP32 Technical Tutorial. In this edition we're going to talk about core dump processing. Now the notion here is that when we write an application program, that application program may not work the first time. Gosh forbid. For me, every program I write runs first time, every time. I wish, but it's not always the case. So we can be writing an application, we can run our program, the program runs, and then it crashes. So what do we mean by a program crashing, and what can we then do to figure out what's gone wrong on it, and how then we can fix it? So let's look at a simple application. So here's a C application, and delays for a few seconds, goes into a loop, prints an exception is going to happen in so many seconds, and then we call this function myData, and that's the end of the program. Sounds easy enough. So let's go ahead and compile this thing and deploy it. Well, I've already compiled it, so I'm just going to run make monitor, and let's watch it run. So my ESP32 starts up. It logs those messages. An exception is going to happen in so many seconds, and then bang, the program crashed. So if you've been writing ESP32 programs for a while, this should not be an unexpected condition to you. Gosh, now we have this information in front of us. How do we relate this back to our application? Well, we've got a program counter here, PC. This tells us the address in memory where the exception happened. Apparently it was a load prohibited, but that's about it. Now we can do all kinds of rocket science and command line things, but it's not the easiest thing in the world to get from this back to our code to figure out what happened. Well, in the latest releases of the ESP32 ESP-IDF, there is a concept called a core dump. Now the idea behind a core dump is that when a program crashes, the stack and various other data related to the execution of the program when it crashed can be captured and logged. And then if we format that log or that dump of the core of information or the core of the computer, we can format that and we get a representation of where we were in our program. So let's go ahead and do that. To enable that, we would run make menu config, the standard ESP32 ESP-IDF configuration. We go into component config, ESP32 specific, and we see this option, core dump destination. Now the default is none. Now we get three choices for this: none, flash, and UART. Now none basically is the default and does nothing. No core dump is generated. The flash option saves the core, saves the data in an area of flash memory as defined by something called the partition table. Now that's very useful, but I'm going to bypass that for just now. I'm going to focus on using the UART. So I select the UART, and we're now selected for UART. The other thing that we need to set is I'm looking for it, the panic handler. So what should the ESP32 do when it detects a crash? Now the default is print registers and reboot, which means everything will scroll off the screen and we won't be able to see anything. So I changed this to print registers and halt. So that's what I set mine to. Print registers and halt causes the ESP32 to come to a grinding halt when an exception is detected. So with these two changes, setting the UART setting the core dump destination to UART and setting the print registers and halt for the panic handler, I save this, and now I rebuild my application. I'm using make -J5. The J5 flag basically leverages all the cores in your machine. I believe it's cores +1. I've got a 4-core machine here, so I'm doing make -J5, and that is using up to 5 cores for my compilation. Makes it faster. So now I'll run make flash and monitor. So now I'm pushing my application to the ESP32, It only takes a few seconds, and then once that's done, the program will run, and we're monitoring. So now again, the program is running. We should expect an exception in 3, 2, 1, bang. And now we get this thing called a core dump. Now the core dump is this text. Whole bunch of text. Now this is an encoded piece of binary data. So it's base 64 encoded, and what I'm going to do is I'm going to copy all that data. Copy, 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 copy from here. I'm going to copy it into my clipboard. I'm going to create a file. I'm going to call it core.dat, and I'm going to paste that file in here. So now I've got a file in my file system on my Linux machine which contains this core dump data. Now, if I consult my notes, this is basically the notes where I document what I'm doing. We get the core dump data. Now, once we've done that, we can run this script. This is a script supplied by the ESP32, and let's go ahead and run that. So let me copy this command, and let me go here, and let me run that command. And when I run that command, it decodes the core dump data. So now we're looking at some information. So what are we seeing here? An eye catcher at the beginning saying it's a core dump. Again, the registers. Again, that's nothing new, but now we get our goodness. So this was the current thread that was running when the exception occurred. It was in the function show data. Oh, that's useful. So now at least we know where in our code we failed. And here is the actual line number in our source code where the exception occurred. So this is the path to my source code. Line 13 is where the exception occurred in the show data function. And if we go back to my application, show data, line 13, apparently we were trying to find the length of a string that was contained in the S property of data, and if we work backwards from there, we go, oh, my data was null, so I was trying to reference a parameter in a null pointer, and hence an exception. So this has immediately told us the line number in our code where the exception occurred. Now, it's not going to go any further than that, unfortunately. It's not going to tell us you passed in a null variable, but it will tell us exactly the source line statement where we failed. So again, in my source, it was line 13, and we can see here the current thread stack where the exception occurred was here. We're also shown, just as a byproduct, all the other ESP32 RTOS tasks running in our environment. Now, for this example, that wasn't important. It shows us here that the main task was the one where the exception occurred. Again, we're logged here, but we can see all the other tasks running in the system. We also see the address ranges where data is mapped into the address space of the ESP32. Again, not particularly useful for this example, but perhaps useful for others. And that's it. A powerful, powerful technique. So if and when an exception occurs, we can drop a core dump, we can copy that core dump into a file, and we can run the command to format the core data into this human readable format and see exactly what source line the exception occurred in. I hope you found this useful, and I look forward to making more of these videos in the future. Thanks guys, and bye-bye.